Welcome to solverfy.
Here we have to, here you submitted an assignment. So therefore I've had to solve it in advance, and I'm going to walk you through the solution because it's quite a long assignment. So in the first one, we have to calculate the number of millimoles of NaOH, which is required to react with 50 milliliters of 2.5 molar of H2CO3 to form a solution with a pH of 10.00. So pKa of H2CO3 has two pKa's, which are 6.35 and 10.33. So 10 is close to pKa2, therefore here we have a buffer of HCO3 and CO3, so carbonate by carbonate buffer. So now let's calculate the ratio of CO3 to HCO3 in this buffer, which would provide pH of 10. pH can be calculated according to this formula. So then we can calculate the ratio. We can calculate concentration of CO3 minus, CO3 2 minus as a function of HCO3 minus. So the coefficient is 0.468. Now let's look at the reaction between H2CO3 and NaOH when they react in 1-to-1 stoichiometry. So this reaction leads to the formation of sodium bicarbonate, and at least 125 millimolar of NaOH is needed to complete the step. Therefore, we already can choose the answer, but nevertheless, we'll continue the solution. So when the first step is completed, extra NaOH reacts with NHCO3 and forms sodium carbonate. And here what we need to do, we need to presume that X moles of NaOH reacts with formed carbonate. So therefore, the amount of bicarbonate left is 0.125 minus X, and the amount of carbonate formed is X. So then we just use this coefficient, and we calculate that X equals to this number of moles. So that's extra NaOH, which is needed to react with bicarbonate to form carbonate. And then basically what we do, we just add this amount to this number of moles of NaOH which was added for the first reaction. And so the closest answer is 170 millimolar. So question 1 is solved. Now let's move on. In question 2, we have to predict the pH of a solution which is formed upon mixing 30 milliliters of 1 molar HBr and 30 milliliters of half a molar ammonia. So these two chemicals react in 1-to-1 stoichiometry, and therefore, as we can see, HBr is in the excess because its concentration is twice larger. So therefore, the final mix will have extra HBr, and therefore the pH will be strongly acidic. In the last question, we have a reverse situation. So to 60 milliliters of 1 molar HNO3, 100 milliliters of 1 molar ammonia is added. Now, ammonia is in the excess, and therefore, after the reaction, it will form a buffer where amount of NHNO3 is 60 millimolar and amount of NH3 is 40 millimolar. Now we can calculate pH of this buffer according to the formula shown here. And here NH4 plus is acid, and this pH is 9.07, which is weakly basic buffer. So here is the solution of this problem. I hope I helped you. Thank you very much for your attention. Bye.